Hi, welcome to this lesson on the geology of the moon. I know it's going to be a bit strange working like this, but with a combination of your hard work and lots of support from me, I'm sure we can make it work and find our way through the rest of theme 2. The first lesson is all about the geology of the moon. This is a view perhaps we're all familiar with. On a clear night with a full moon, we can see this view even with the naked eye. I want us to think a little bit more about the geology though. What are we actually seeing when we look at the moon's surface like this? You can see there are some different features. So for our first activity, on page 10 of our booklets, I'd like you to list 3 geological differences between the Earth and the moon. Remember to keep them geological. What features do you think are here? What can you identify? And perhaps you can start to think about how you think each of these features actually formed. You do need to look carefully and think carefully about this. So while you're doing that, press pause and see what ideas you can come up with. Okay, let's have a look at some more of the information about the moon that will help us start to unpick its geology. Let's look at the rocks first of all. These are the 2 rocks that we would be looking at in class if we were looking at the hand specimens. On the left we have specimen Y and on the right specimen V. You can see these are both igneous rocks. They both have interlocking crystals, but there's a very obvious difference between them. We have the darker rock on specimen Y, the lighter rock on specimen V. If you look at your image of the moon, you'll see the 2 areas on the moon, the 2 distinctive parts of the moon's surface, indicated by their different colour. And it's these rocks that create that different colour. Specimen Y is a rock called a basalt. This is one of the rocks that you need to know for your GCSE course. Specimen V is a rock filled with a mineral called feldspar, called anorthosite. You don't need to be able to identify this one, although you do need to be able to recognise feldspar when we see it in a rock. Let's find out a little bit more about what the moon is made of and how we were able to investigate this using both examples from Earth and samples from the moon brought back by the Apollo astronauts. Watch this video to explain more. A simplified map of the moon. Unfortunately, this map shows the darker areas in reality as lighter colours and the lighter colours as dark ones. It's a pity, but this simple map shows us pretty much the same view that you can see in the photograph of the moon. Now, these 2 different areas are punctuated by some major impact craters. You can see here we've got Tycho, we've got Alphonsus and Copernicus. Copernicus is going to be the subject of a lesson a bit later on in the theme. The lighter coloured surfaces on your photograph are what we call the lunar highlands. They're called the terrae. These areas you can see are made of this anorthosite, and they are slightly different from the darker areas. The darker areas are what we call the mare. These are Latin words. Terrae means land, mare means sea. The ancient astronomers, when they were looking at the moon through early telescopes, thought these dark areas must be the seas, hence the name. What they are basaltic lava flows. We'll look at those perhaps in a little bit more detail. Is there any information now you can add to your photograph? If we try and add a little bit more information to this, we can see, although the rock is igneous, it's made of by volcanoes, we don't see any active activity. We can, though, see meteorite craters, far more so than we see here on Earth, even though Earth, being bigger, must have had more meteorite impacts. The moon hasn't got any atmosphere or any liquid water on the surface. So the surface we see is actually one that's been frozen in time over a very, very long period. As a result, we see, if you like, a snapshot of perhaps what the early Earth looked like. Is there any more information that you can now add to your photograph? Look carefully at the terrae. Notice how there are far more meteorite impact craters on the terrae than there are on the mare. That's something we're going to explore a little bit more next lesson. So, to conclude, there are lots of interesting geological features that we can observe on the moon's surface. Each one of these features starts to give us clues about how the moon formed, and as a result, what conditions were like on the early Earth. Make sure you've got page 10 fully completed. Next time we're going to look in more detail at a small part of the lunar surface.